So my question was, and one of the things I learned a couple of months ago was that you had the opportunity or were offered a position with Warner Von Braun's group, and I wonder if you could elaborate on that.
Oh, yeah. Well, I had interviewed actually at Huntsville, Alabama, with Von Braun's people. And so I was looking forward to getting getting an offer from them. I thought the interview went really well, and they were testing rocket motors, and there's a problem of vibrations on the test stand, and I went to the blackboard and showed them that illustrated one of the vibration problems could be associated with the electronic instrumentation, but it could also be associated with vibration of the rocket motor on the test stand itself. And I outlined the mathematical equations for solving those two different problems. So there was an electronics and instrumentation problem involved on the one hand, and mechanical vibrations on the other hand. And they seemed impressed that I would work problems in the electronics world as well as the mechanical world. And so I thought the interview went pretty good, but as time went on, I didn't hear from them. So I then accepted another job with the Navy propellant plant. And after getting that job, I did get an offer then from Von Braun's group. But by then, I was so engrossed in my job at working on the Polaris rocket motor that I declined their offer. And but I was kind of torn between leaving the Polaris rocket motor versus going with Von Braun's group. But I was having so much fun with the Polaris rocket motor, I did go ahead and decline their offer.
What your future plans are with regard to maybe some short-term things you're doing currently at Signalysis?
Well, one of the things we did when I was at NASA, I developed a method of detecting damage on the internal structure of the orbiter after flight. I think I mentioned in earlier comments that I would take a crew down to the Kennedy Space Center, and we would perform vibration testing on the space shuttle before a flight. And then I would actually do an experimental model and also a mathematical finite element model of the orbiter structure. And so then when the space shuttle would return from flight, I would go back down and obtain post-flight vibration data. And I was able to use those results comparing with the pre-flight to determine whether there had been any structural dynamic damage. And I actually developed a method of pinpointing the location of the damage using vibration equations. So ever since then, since coming to Signalysis, I've always thought about using that same concept on the assembly line. We already are using the old NASA technology to detect whether a manufactured product has a defect coming down the assembly line. So we routinely have been detecting defects using vibration for a number of years now, but I've never yet taken the step to try to show the customer where in the product his defect is. Some of these components we test are pretty complicated geometrically, and it would be quite a challenge to be able to tell them inside of a structure where their damage is located. But they would like very much to know where the damage is. And of course, I've got that methodology in my toolkit theoretically. It's just a little more involved mathematically and involves computer graphics and product modeling. And but I keep thinking about that. And over the years, that's been one of my dreams here at Signalysis, is to try to implement that NASA method to actually be able to tell a company where the damage in their product is located internally. So I've been working on a method of doing that. The problem is a lot more difficult on the assembly line. When I was at NASA, I could take 2 or 3 days to apply the analytical methods to locate the damage on the space shuttle. However, here on the assembly line, we have to be able to complete our test within several seconds because they have a steady stream of products coming down the assembly line, and they need an instantaneous answer about whether they have a defective product or a good product. And if I'm going to locate the damage, I don't have 2 or 3 days to do it. It's got to be done in several seconds. So I've been working on that, on a process for doing that. And we'll have to see if it really is going to come to fruition. But that's really my dream here now, is to try to be able to immediately tell, have a picture of the customer's product on the computer screen with a red spot right on the point that is damaged. And we would have to have detailed computer graphics. We could we would be able to do exploded views, go in and look on the inside, show an inside view of the product with a red spot right where the damage is.
Right.
Yeah, customer would be very delighted to be able to have that ability.
Yeah, no, that sounds like it's, yeah, it would be quite a breakthrough. I think you mentioned a couple years ago to me that you, as a youngster, maybe your parents had you involved in music quite a bit, and your interest at that age was with music. And I believe you mentioned in the Navy you were a bugler on a ship or a carrier or something. And can you, in a couple of minutes, talk about how you went from that to the world of vibration?
Yeah, I think really there is a connection of my interest in vibrations as a physicist. I think there is a connection all the way back to, I can remember all the way back to age 9 and 10. My father was a piano tuner, and my mother was a piano teacher. So, my mother gave me piano lessons beginning at age 5. And I actually had ideas of becoming a concert pianist growing up. even in high school, I was working toward that goal. And I actually initially went to Arizona State University on piano scholarship and also on a trumpet scholarship. And my dream at that point was to be a musician. But then, without going into details, I joined the Navy and actually went to the Navy Music School and was a Navy musician on an aircraft carrier. But after having experience in the Navy, standing watches on the bridge and interacting with some electronics technicians and engineers up on the bridge, I got real interested in physics. And when I got out of the Navy, I just went to University of Oklahoma and pursued a career in physics. But going back to age 9, my father was tuning pianos, and every summer he would go on these long trips around the state of Arizona, tuning pianos at colleges and high schools and private residences. And he would take me along, and he would have me move the mutes on the piano strings. When he would tune a piano, each note in the middle of the piano had 3 strings for one note, and you had to tune those 3 strings to exactly the same pitch, or you would not get a pleasing uniform sound. And so he had to tune 1 string at a time, and he had to mute off the other 2 strings. So he had rubber mutes that he used to mute off the other strings so he could tune just 1 string. Well, he paid me 50 cents per piano to move the mutes for him. And so I, at the age of 9, 10, 11, 12, I had that experience of listening to him repeat the sound of the notes over and over and over again and tune those strings. And I became very fascinated with the changing pitch of the string as he brought the notes into true pitch. When he would start, the note would sound bad. And by the time he finished, the 3 strings sounded as 1 string. And I was fascinated by that. And as a part of that tuning process, you had to learn to tune your ear to some very high frequency harmonics. If you hear a piano sound, you don't even notice that there's really a whole series of different tones or pitches that are being that are part of that sound. And in fact, the reason we have differences in quality of sound between different instruments is because all of those high frequency harmonics sound in different intensity ratios for different instruments, giving you different sound qualities. That's why a trumpet doesn't sound like a piano. Mm-hmm. So anyway, it's that history of just wondering about what was going on with these strings and the sounds and the frequencies that interested me, and that led naturally into an interest in vibrations as I engaged in the physics curriculum in college.
So you were doing some work on the Polaris rocket program, I assume that was roughly the same time that the Mercury program was going on with NASA. Was there any information shared back and forth with regard to rocket technology, or were they both operating autonomously?
Well, the Polaris rocket motor was pretty much independent, an independent project there. And it was in later years that I went to NASA. And of course we did, NASA had its own rocket motors. And so, they had the solid rocket boosters. And that of course was very interesting to me. And I was interested in vibrations associated with the space shuttle rocket motors as well. So we did, when I would go to the down to Kennedy Space Center, we would measure the natural resonance frequencies on the space shuttle. And then I could get some vibration data. Accelerometers were installed on the space shuttle to measure vibrations during the flight. That way I could, after flight, I could get the vibration data and tell whether any damage was developing on the space shuttle, just based on the analysis of the vibration data. And of course, the vibrations in the solid rocket motors themselves were a big source for vibration damage. There were two primary sources, really: the external aerodynamic shock waves going through Mach 1 that caused vibration on the structural surfaces, and but also the solid rocket boosters generated quite a bit of vibrational forces just from their internal acoustic modes of vibration. And I was very familiar with that process after having worked on the Polaris rocket motor, because the Polaris is really where I learned how internal rocket motor resonance frequencies played in to the vibration problem leading to structural damage.
So didn't you also mention that payloads have an effect on vibration?
Oh, that's right. Yeah. Yeah. When a payload is mounted in the payload bay of the space shuttle orbiter, as that shuttle goes through, particularly when it's going through Mach 1, and a lot of structural vibrations are induced, again, by the solid rocket motors and by the shock waves. Those vibrations are present in the mounting structure of the payload bay. So the payload mounted inside the bay is getting vibration inputs from the structural mounting that it's coupled to. So then if the payload itself has resonance frequencies, then its resonance frequencies amplify the vibrations that are applied from the space shuttle payload bay mounting structure. So if the payload has dangerous resonance frequencies, particularly frequencies that happen to match the frequencies in the payload bay, then you can have catastrophic failure of the payload, and the payload could even rip off of its mounting structure and be free to just fly around the inside of the payload bay and cause a disaster. So it was very important to test every payload before it was installed in the space shuttle to validate its integrity for vibration safety. So we always tested the payloads before they went into the shuttle, and we found the resonance frequencies, and we could analyze. We did mathematical models of the payload, and we had a mathematical model of the space shuttle, and we could mathematically couple the payload to the space shuttle in our computer models. And then we could simulate the flight of the shuttle going through Mach 1, and we could predict the level of vibrations that you would have on the payload, and we could predict whether those vibrations would be severe enough to cause catastrophic damage. So, so every payload had to be certified as safe for vibration.
You kind of mentioned to me in the past that you really enjoyed your days at NASA. Do you have a favorite story from those days?
Well, I guess my favorite story is just simply having the experience of an astronaut coming into our building where I was working at NASA, coming into the office. One day I'm sitting in the conference room in a meeting. My boss called me into the conference room and said, Bob, we had a meeting a couple of days earlier about some project. And he said, I just wanted to clean up a couple of items on that project we were meeting on. And so he brought me into the conference room, and there were several other engineers there. And then the top manager of the facility came in the room, and then following him was an astronaut, Kent Rominger. Kent Rominger, the astronaut, came in the room, and I noticed that all of the other engineers were getting up from the table and moving, standing back against the wall. And I was sitting there at the conference table all by myself, and the astronaut's coming in the room. And all of a sudden, the astronaut starts talking and indicates that he was there to present me with an award. And I was just flabbergasted. The astronaut had a poster-like award with him called, on the poster, it was called the Silver Snoopy Award. And the astronauts had what they called the Silver Snoopy Award. They had actually collaborated with the cartoonist of Snoopy, and they cooperated with the artist and got him to develop a painting of Snoopy wearing an astronaut suit, and they had that caricature on the on this award. It was a big poster-sized award, and he pulls it out all of a sudden and holds it up and starts talking to me and reviewing the reason why the astronauts had selected me for the Silver Snoopy Award. I just didn't know what to do. I was so taken back. It turned out they were giving me an award for developing the method of using vibration technology to identify structural defects on the space shuttle that had occurred during ascent and the return flight. And so he elaborated on how important it was to them to have comfort knowing that somebody was analyzing their structure and giving them information that could potentially save a catastrophic flight. And so I was just overwhelmed. So they presented me the Silver Snoopy Award, and I still have it hanging on my wall at home. And yeah, there's no question about it. There's not any other experience I've had in my career that equaled that experience.
So are they still, for the most part, using that same methodology you developed for that?
That's really basically what we're trying to do here at Signalysis, applying that same damage detection technology to the assembly line. So we really have literally engaged in NASA technology transfer for assembly line product damage detection.
Is there anything that we haven't touched on that you think might be important to mention, either with your work or the industry in general? I mean, I'm assuming that vibration is vibration, no matter if it's 1960 on a launch pad, or if it's a space shuttle, or if it's a product coming down the assembly line. What do you see as a common thread between all these things?
Well, the common thread, of course, is the underlying technology and the theoretical basis that underlines all of these vibration applications. And so the underlying physics. So it and along another part of that, I guess, still is that unending connection all the way back to a 9 or 10-year-old boy being intrigued by the sounds of the vibration of a piano string. So that intrigue has always been a part of everything I've done with vibration applications.
So you had to do it the hard way back then with math and pencils and slide rules. I mean, today's technology's come quite a way since then. Is that rewarding for you to know that you solve problems the good old-fashioned way?
Yeah, and there's one fundamental differential equation that is at the root of the understanding of vibrations, really. And if we had a whiteboard here, I would go to the board and write that equation out for you. But usually, if I'm with my son, Neil, of course, is the president and founder of Signalysis. And when I would go with him out to visit a customer, and he would have me give a little explanation of our technology, as soon as I got too involved and began to make a move toward a blackboard to write an equation, he had a way of shutting it down right there. He didn't want to go into equations because he realized that really our customers really aren't too interested in the mathematical details.
Well, thanks, Bob. I appreciate you getting out in the rain today.
Okay, well, thank you very much for all of your help.